Hi guys, I want to add a few more examples of learning target number 5, and I'm going to do questions from the review. So the first one we have here is a rocket is shooting upwards at a constant velocity of 80 meters per second. The rocket drops its first set of boosters on accident 20 seconds into the flight. Okay, so this first part here, how far do the boosters fall? Well, let's see how high up that rocket got with that constant velocity of 80 meters per second for the first 20 seconds. Okay, so let me pull up this. All right. So let's draw a picture and establish an origin. We have our rocket and it launches, and at some height into that launch, the rocket boosters release. I think they said 20 seconds into the flight. Okay, so there's my image. I'm going to call where my rocket started the origin. And so when that's the case, my initial position of the rocket is 0 meters. Okay? X final would be what I'm solving for because I want to know how high up we were before the rocket boosters released. My average velocity is 80 meters per second. Okay, so that was an average, and then let's just remind myself. Let's see. So we have 80 meters per second, and then it was after 20 seconds into the flight. Okay, so time initial is just 0 seconds. Time final is 20 seconds. Alright, so we have, I added a couple more zeros on just so we have the same amount of sig figs as our other values there. We want to know X final. Well, we have, and when you take your test, have your reference sheet, because velocity average is a change in position over a change in time. Okay? So velocity average delta x divided by delta t, so that's just x final minus x initial divided by time final minus time initial. Okay, let's get rid of our 0 values. X initial is 0 and time initial is 0. So for this example, velocity average is x final divided by time final. Okay. And now let's get x final by itself. So let's rearrange this to get x final by itself. So I'm going to multiply t final to both sides. So x final is equal to t final multiplied by that average velocity. Okay, so we have those components there. T final is 20 seconds, and our average velocity is 80 meters per second. Okay, and plug that in. Okay, 1600 meters. Now we have 3 sig figs, and then if I leave it just like that, that would be 2 sig figs. So I actually need to write this in scientific notation. I need to write it as 1.60 because that would give me 3 sig figs. Times by 10, I move that decimal 1, 2, 3 times. Okay, that would be my final answer for part A there. That's how high up the rocket was when it released the boosters. Okay. Now, what was part B? How fast are they falling when they hit the ground? Okay. So this one we're going to treat a little bit different. So that was part A. Part B, our picture is different now. So now we're saying our rocket was up here, it released the rocket booster, and now that booster's falling to the ground and it's going to hit the ground. Okay. So in this situation, I'm going to say where this rocket booster started, up here. That's going to be my initial position. That's going to be my origin. So if this is my origin, I'm going to say going down is negative, going up is positive. And I'm going to make a list of values that I could potentially be finding. So x initial, x final, velocity initial, velocity final, acceleration, time initial, time final. Now if you write this list down each time, it's going to help you to avoid missing out on important information that you might not have clearly been seeing before. X initial, because I chose this to be my origin, it's going to be 0 meters. Okay. X final is this distance that it fell, and we solved for that last time. But see how it's in the negative direction from where it fell? So this is going to be negative 1.60 times by 10 to the third. And that's because I chose that to be my origin. So I'm negative this distance to the ground, okay, for my x final. Velocity initial, okay, well, the initial velocity, let's see, let's read through that one more time to see what's going on there. So a rocket is shooting upward at a constant velocity of 80 meters per second. The rocket drops its first set of boosters on accident 20 seconds into the flight. How far do the boosters fall, assuming they stop burning when they are released? Okay, so assuming they stop burning, that means that the initial velocity is 0 when that release happened. Okay, so back to this. So my velocity initial is going to be 0 meters per second. Velocity final is what I'm solving for, because the question said, how fast are they falling when they hit the ground? So that would be that final velocity when they hit the ground. And acceleration is my acceleration due to gravity, so that'll be negative 9.81 meters per second squared. Negative because that acceleration is down towards Earth. Time initial is 0. Time final we don't have. We knew how long it would take the rocket from the question before. It told us how far before it released, how long before it released the boosters, but we don't know how long it's going to take for them to fall to the ground, so we don't have that piece of information. So we need to pick an equation where our only unknown is what we're solving for, velocity final. So we do not want an equation that has time final. Let's see if we have something there. Okay. That one has time final. This one does not, so we could use that one. That one has time final, and that one has time final. So our only option here for our kinematic formulas is this one. Okay, so I'm going to write that down. Velocity final squared equals velocity initial squared plus acceleration, plus 2 times acceleration. 2 times by acceleration times by delta x. So I'm going to write that one more time. Velocity final squared, velocity initial squared, plus 2 times by acceleration. I'm going to open up that delta x final minus x initial, and let's get rid of our 0 points. Okay, so velocity initial, that's at 0, and time initial, or sorry, position initial, that's at 0. So velocity final squared is going to equal 2 times by acceleration times by x final. Okay, and then the last part of this, let's take the square root of both sides so that we have velocity final not squared, and then the square root of 2 times by acceleration by x final. All right, last thing, let's plug them in. So 2 times by acceleration, which was a negative 9.81 meters per second squared. Okay, and then we're multiplying this by x final, which was negative 1.60 times by 10 to the third meters. Okay. Let's see what our calculator gives us. So we're going to take the square root of 2 times by negative 9.81 multiplied by that negative 1600. Okay. It says velocity final is 177. Now let's see, we have 3 sig figs. We have 3 sig figs. This was part of the equation, so it's an exact number. So we're not worried about significant figures with that one. And so our final answer will have 3 sig figs, so that's 177 meters per second. Okay. Now, this is how fast it's hitting the ground, and we've established that this is the negative direction. Because this equation has squares, and we have to square root often, sometimes we lose that negative. So it's important to look at your image and to say, this is hitting the ground with this velocity, but also that's in the negative direction. Okay. And let's confirm what we had on here. Let's see. How fast are they hitting the ground? So that doesn't necessarily mean velocity, like you don't have to include the units on that one. And I have the test set up if you come across a problem like this, that if you put the positive version or the negative version, that you get full credit on that. Okay. All right, guys. I'll add a couple more videos here. I'll do a couple more of these problems if you want to keep practicing.